Hello everyone, very warm welcome to Venkat Varma Chemistry YouTube channel. I am Venkat Varma, your chemistry host and enthusiast. I hope all are doing well. First of all, thanks for clicking the video. In this session, I am going to explain discovery of electron related to atomic structure. Discovery of electron. See, before going to the details of discovery of electron, we need to keep in mind basic rule. Like charges are repelled and unlike charges are attract to each other. See, what is a basic rule? Like charges are repelled and unlike charges are attract to each other. So, electron discovered by J.J. Thomson by using cathode ray discharge tube experiment. So, the electron discovered by the J.J. Thomson, the name is given by J.J. Stoney. J.J. Stoney. So, name of experiment is cathode ray discharge tube experiment. Electron discovered by J.J. Thomson. The name is given by or proposed by J.J. Stoney. So, first of all, what is cathode ray discharge tube? What is cathode ray discharge tube? So, the discharge tube is a sealed tube and made up of glass containing two metal plates are called electrodes. Two metal plates are called electrodes. See, have a look for this. This is the discharge tube. Discharge tube is a sealed tube made up of glass containing two thin metal electrodes. These are the electrodes, cathode electrode and anode electrode. Anode electrode. See, next. So during the discharge tube experiment, Crookes observed that the rays are found to pass from negative charged place to negative charged plate to positive charged plate. Means anode, cathode to anode, cathode to anode. See, during the discharge tube experiment, Crookes observed that rays are found to be passed from negative charged plate to means cathode to anode plate or positive charged plate. Okay, next the electrical discharge tube. The electrical discharge tube gases could be observed at very low pressure, that is a 0.01 mm of Hg, and very high voltage current, that is a 10,000 volts. That is a 10,000 volts. The discharge tube experiment applied the conditions at a low pressure, high voltage current. So low pressure means it is a 0.01 mm of Hg, at high voltage current is a 10,000 volts. The rays are emitted from cathode to anode. The rays are emitted from cathode to anode. These are cathode rays. These are cathode rays. Cathode rays are stream of electrons. Cathode rays are stream of electron. Cathode rays are stream of electrons. See, what are the properties of cathode rays? What are the properties of cathode rays? See, cathode rays moves from cathode to anode. See, cathode rays are moves from cathode to anode. Cathode to anode. Next what? See, the rays are invisible. These cathode rays are invisible rays, but their behavior can be observed with the help of fluorescent or phosphorescent material which glows when hit by them. When the rays are invisible rays, but their behavior can be observed with the help of zinc sulfide screen or fluorescent or phosphorescent material which glow when hit by them. See, these rays travel in straight line. These rays are travel in straight line. The absence of electric and magnetic field. Absence of electric and magnetic field. These rays are traveling straight line. Yes. Next, see. In the presence of electric field, they are deflected towards anode. For example, electric field means this is the electric field. For example, I am applying the electric field. These rays are deflected to positive side because these are having negative charged particle. These are negative charged particle. These are deflected towards anode. and in presence of magnetic field it towards south pole. See, in presence of magnetic field, in presence of magnetic field, so we are applying the magnetic field in this experiment. So for example, it is north pole, it is south pole. See, they are deflected towards south pole, they are deflected towards south pole in presence of magnetic field, in presence of magnetic field. Yes. Now cathode rays contain, cathode ray contain negative charged particles. These are negative charged particles are called electron. These negative charged particles are called electrons. Next, see, the rays, the nature of cathode rays found to be independent of nature of the cathode material and the nature of gas in it, the tube. So the nature of cathode ray is found to be independent of nature of the cathode, independent of the nature of cathode, and nature of gas fell in the tube, fell in the tube. Hence, electrons are considered as constituent particles of all the atoms. Hence, the electrons are considered as constituent particles of the atoms. These are called cathode rays. These are called cathode rays and cathode ray particles. Next, see, in the absence of electrical field or magnetic field, they are traveling straight line. Yes, they are traveling straight line. Yes. So cathode rays discharge tube with perforated anode. It is a perforated anode. It is a perforated anode. Cathode rays discharge tube with perforated anode. See, the flow of the flow of current from the flow of current from cathode to anode. The flow of current from cathode to anode can be checked by making a in the anode, hole in the anode, and coating with tube behind the anode, tube behind the anode with phosphorescent material or zinc sulfate screen. Zinc sulfate. This is a zinc sulfate screen. Fluorescent screen or zinc sulfate screen. The flow of cathode to anode can be checked by making hole in the anode and coating with the tube behind the anode with phosphorescent material or zinc sulfate material. See, these rays after passing through anode strike the zinc sulfate. These rays are passing after these rays are passing through anode strike the zinc sulfate screen. Strike the zinc sulfate screen. This is the zinc sulfate screen. Next, cathode rays are made up of particles as they rotate a light frictionless paddle wheel. So, cathode rays are made up of particles. Cathode rays are made up of particles as they rotate a light frictionless paddle wheel. The flow of current from cathode to anode can check by making a hole in the anode and the coating with the behind the anode with the zinc sulfate screen. Yes, the these rays after passing through anode strike the zinc sulfate screen. As a result, a bright spot develop on the screen. The same particle, the same principle involved in the television set. The same principle is involved in television set. In the absence of electric and magnetic field, cathode rays are anode rays. Sorry, cathode rays are traveling straight line. Yes, these are moves straight line. Presence of electric and magnetic field, they are deflected towards opposite charge. These particles are called negative charged particles. The negative charged particles are called electrons. The characteristics of cathode rays. So they do not depend on the materials of electrode and the nature of gas present in the cathode ray tube. It is independent of nature of gas filled in the discharge tube. The basic constituent of all atoms are electrons. The basic constituent of all atoms are electrons. Cathode rays are not formed in evacuated discharge tube. Cathode rays are not formed in evacuated discharge tube. Cathode rays ionize the gases, indicate proving that rays are charged particles are charged. Cathode rays ionize the gases. It's indicate that they are charged. They are charged. See, look at for next charge to mass ratio of electron. So before that what? Discovery of electron. Electrons are having the negative charged particles. We are using the electrical discharge tube experiment. Electrical discharge tube experiment. Next what? See, charge to mass ratio of electron. Charge to mass ratio of electron or specific charge of electron. Specific charge of electron. Have a look for this. See, charge to mass ratio E by m of electron. The charge to mass ratio is known as specific charge. Specific charge. J.J. Thomson measured E by M ratio of the electron based on following points. J.J. Thomson measured E by M ratio of the electron based on the following points. What are the? See, the apparatus to determine the charge to mass ratio of electron is the E by M ratio. E by M ratio. It is a cathode. It is a cathode electrode. So it is a anode electrode. Cathode and anode electrode. It is a electric field. It is a magnetic field. This is the electric field. This is the magnetic field. Magnetic field. See, have a look for this. If when only applied the electric field, only applied the electric field, the electron deviated from their path and hit the cathode ray tube at point. So it is electrical field. So these are rays are deflected towards a point. Yes, at the a point. When the electric field is applied, the electrons are deviate from their path. Electrons are deviate from their path, hit the cathode ray tube at a point. At a point. See, have a look for next. By balancing both electrical and magnetic fields, the path of electrons can made a straight line. So we are applying the electric field and magnetic field. Magnetic field, they are traveling straight line. They are traveling straight line. That is the B point. That is the B point. See, if using magnetic field, so if only using magnetic field is applied, the electrons deviate from their path, hit the cathode ray at the C point. C point. It is north, it is south. See, it hit the C point. Okay, next, see. The amount of deviation of particles from their path in the presence of electrical or magnetic fields depends on. So the first factor is magnitude of the negative charge of particles. The first one is, see, the amount of deviation of particles from their path in the presence of electrical or magnetic field depends on magnitude of the negative charge on particles. See, the greater the negative charge, greater in the interaction with electric or magnetic field, thus the greater the deflection. The magnitude of the negative charge on the particle, greater the negative charge, greater the interaction with electric or magnetic field, thus greater the deflection. Second, the mass of particle. Mass of particle. See, mass of particle, lighter the particle, higher the deflection. Mass of the particle, second factor, lighter the particle, higher the deflection. See, now third factor, the strength of electric or magnetic field. See, the deflection of electron from their original path increases with increasing the voltage across the electrodes or strength of the electrode. Strength of electrode or strength of magnetic field. See, the deflection of electron from their original path increases with increasing the voltage across the electrode or strength of the electrodes. By carrying the accurate measurements on the amount of deflection observed by the electron on the electric or magnetic field strength, the Thomson was able to determine the E by M value. E by M value, that is a charge to mass ratio. So charge by mass equal to specific charge. So E by M of electron, it is a 1.758820 into 10 power 11 coulomb per kg. So charge of electron equal to minus 1.602 into 10 power minus 19 coulomb. Mass of electron, it is equal to 9.11 into 10 power minus 31 kg. It is a charge, specific charge of electron. Specific charge of electron. Next, see. As the velocity of electron increases, see, as the velocity of electron increases, as the velocity of electron increases, so velocity of electron increases, specific charge of electron decreases. So E by m electron is decreases due to increasing the relative mass of the electron. So velocity increases, E by m value of electron decreases. What is the reason? Due to increasing relative mass of the electron. So the mass of moving electron may be calculated by applying the formula. What is the formula? See, have a look for the mass of moving electron calculated by applying the formula. What is the formula? It is a m equal to, it is a m equal to m naught, m equal to m naught, see, under root 1 minus, see, nu by c, nu by c whole square. This is the mass of moving electron, mass of moving electron calculated by m equal to m naught under root 1 minus nu by c. So what is a m naught? M naught is a what? It is a rest mass. It is a rest mass of electron. Rest mass of electron. What is the m? Mass of moving electron. See, mass of moving electron. Mass of moving electron. So what is the new velocity of electron? Sorry, what is the v? Velocity of electron. Velocity of electron. Yes. C is the velocity of light. Velocity of light. Yes. Now, if the condition is V equal to C, V equal to C, V equal to C what? When V equal to C, what happened? See, mass of moving electron, mass of moving electron, mass of moving electron becomes infinity. Mass of moving electron is, what is the condition? V equal to C, the mass of moving electron becomes infinity. Yes, see.